Hello everyone, welcome to Network Signals for CCNA routing and switching. Today we will discuss and configure the OSPF. OSPF is nothing but Open Shortest Path First. So it is the second generation of the dynamic routing protocol. So it is the one of the IGP protocol. IGP means Integrated Gateway Routing Protocol. It will communicate only the same autonomous number system. Same AS value. OSPF versions. It started in the research of 1980s in ARPANET. In 1989, it can introduce the standardize the OSPF version 1. And in 1998, introduced the OSPF version 2. It is mostly used in the IPv6 protocol, IPv4 protocols. In later second generation of IP Internet Protocol in 2008, introduced the OSPF version 3. I already told, so using the multi-cat address to communicate between the routers. Using the IP 220.0.0.5 as well as 224.0.0.6. So it is used the DR router. This is the VDR router. DR router is nothing but destination router. It advertises the routing information across the OSPF routings. VDR is nothing but backup destination router. If the DR is failed, then automatically it takes the overall of the DR. Mainly it is used to Dijkstra algorithm to find the shortest path. SPF. Using the Dijkstra algorithm to find the shortest path between the any two nodes. It have the fast convergence time. If adding the new topology, it will take less time to advertise the routing neighbor router informations within the topology. That's why it having the faster time convergence times. And it is the popular dynamic routing protocols. Mainly it is used for large area network. So previous generation is the RIP protocol. It is also a distant vector protocol. Here is the link state routing protocol. And it guarantees the loop free topology. So it does not occur the loop in the routing paths, loop free paths. It maintains the database in the link state database. I already told OSPF is a link state routing protocol used to route your packets within a same autonomous number systems. It is the popular choice for large network due to the quickly convergence of the changes in the topology. That's how the fast conversion times using the Dijkstra algorithm to find the shortest path between the any two nodes. It having the four key concept in the OSPF concept. You can see one by one. First one is the link state routing. Have to write one by one. After that we will discuss. Next one is the SPF algorithm. You know what is the algorithm is used for the shortest path. Third one is the LSE algorithm. Fourth one is the area. So area is play a major role in the OSPF protocols. Here, link state routing. So link state routing is nothing but in each router a complex view of the net topology. It can share the informations about the directly connected network in the same autonomous number systems. So there are two routers in the OSPF protocol configurations. After the configuring the dynamic protocol, it can share the informations between the routing informations. Next one is the shortest path algorithm. It can use the Dijkstra algorithm to find the shortest path between the any two nodes. For example, there are two routers in the opposite side. It can calculate between the two nodes between the source and destinations. So which one is having the lower value, it can prefer the route. Next one is the link state advertisement. This one is the link state advertisement. It is used to distribute information about the network topology. That is the what are the networks are connected in hierarchy format. This is the parent, this is the child node, this is the grandchild node. That's information. It having the different type of LSE, router LSE. We can see in detail in upcoming video. Next one is the network LSE. Third one is the summary LSE. It's everything about the topology networks. So router LSE, network LSE, then fourth one is the summary LSE. Last one is the area. On a OSPF area, autonomous number systems can be divided into area to reduce the amount of network traffic and improve scalability. Area can help us to reduce the segment of the network and limit the scope of the topology changes. So there are the different areas available. Mainly area 0 is the backbone of the OSPF. You can see multiple area in next video. Here I am using the single area concept. Backbone of the backbone area of the OSPF. So these are the OSPF concept. Let's see the configuration for single area OSPF. Here OSPF protocol using the 89. Here I am using the same previous protocol configuration topology. I can save as OSPF. Just I need to remove the dynamic routing protocol. Go to the So there is no routing protocol, dynamic routing protocol for this topology. So protocols. So, to check any static routing is configured. Yeah, I remove the static route. So static route is mainly need the network administrator. After that, you can see I remove only the static route. This is the default static route. Now here 192.160.1.0, then 2.0, like this. One 172.16.1.0, then 2.0, then 3.0. Reaching the dynamic routing protocol using OSPF to advertise the routing informations. Here this router is directly connected, this area, then this router 1, 2, 3. Here 1, 2. Just simply go to the router. So IP route. Here C is the network ID and L1.1 is the interface IP. Config terminal, router, OSPF. We can use any single autonomous number. So this is the autonomous sister ID. And after that you can configure the network 192.160.1.0 followed by wildcard mask. Wildcard mask means how many IP addresses we can use exactly. It is the complementary of the submask. 0.0.0 255 area 0. In right side having the connected the 2 dot network. Now I save the configuration. Go to the IP protocols. Here OSP phone. This is the autonomous system ID, ASID. Here it can choose the highest IP address, that is the router ID. So this interface having the highest value IP address. By default it can choose which one having the highest value. It can prefer the path. Number of area in the router, only one area. It is the normal, no stub area, NSSC. What are the networks are advertised for these networks? Network discovery. Yeah, I can. This is the AD value of the OSPF router 110 for RIP 120. This is the gateway 2.1. Similarly, we can configure the neighbor router. So what's happened? config terminal. So before that, what other networks are directly connected? So IP route, you can see 172.1.0, then 2.0, then 192.168.2.0. Config terminal, global configuration, then the router OSPF 1. Here 3 networks are connected, 172.16.1.0, followed by wildcard mask, then area 0, using up arrow key to edit the previous command. Here 192. So IP address configuration is must. If you mismatch these configurations, then you cannot advertise the routing informations. Yeah. Now I save the configuration. So IP, yeah, you can see OSPF neighbor agency 192.160.2.2 on serial loading full to loading to. So IP protocols. Here same OSPF value, then highest router IP is the route ID is the 2.1. Here you can compare which one is having the higher value, 192.160.2.2. That is the interface ID. So maximum path 4. Here what other networks are connected? This path is nothing but exchange the routing information via this gateway. This is the router information exchange the between the two routers. Networks. Router ID. Which one having the higher value, it can choose. So this is the OSPF autonomous value. This is the AD value of the two routers. Now we see the routing table. So IP route you can see here 192.172.16.1.0, then 2.0 it can land from OSPF protocol. That's why it can source O. This is the AD value of the 110.110. That is the metric value is 65, then 128. Likewise here in center router 192.160.1.0/24, that is the AD value, then metric value 65, then it is getting the interface via 192.168.2.1, here 2.2. You can see, just a minute. So this is the router 0. It have only the two networks are directly connected. So the OSPF router, neighbor router, it getting the interface via 2.1 in 2.2 interface. So 2.2 is the this interface 110, then 110.1/128. So this type of is getting the OSPF network topology in the neighbor router. I will configure the another router also. Here not having the CLI. Config terminal router OSPF 1. So what are the network topology is connected directly 2.172.116.2.0 followed by submask, then area 0 3.0, which having the IP, highest value IP is 3.1. Yeah, it getting the neighbor adjacency table. I need to save the configuration. So IP protocols. I told 3.1 is having the highest value IP address, so it can choose the router ID. Now we see the routing table. So IP route, you can see the routes. 172. Here it is 172 in backside, then 192, 1.0, then 2.0. So these protocols are getting the via 172.16.2.2 interface. Now we check the any one device in devices. What is the IP address? 1.3. Pin 172.16.3.3. Yeah, got the routes using dynamic routing protocol via OSPF. Here, all the network topologies are advertised in the routers OSPF using dynamic routing protocols. Now we verify the some of the comments. So IP route OSPF. It getting the routing informations from the routers 1, 2, then 3. 3 routers in the via OSPF protocols. Next one is the command. So IP OSPF neighbor. So which one having the neighbors? I told. So this is the neighbor router to exchange the routing informations. It is the 2.1. Neighbor is the 2.2. You can see. So OSPF neighbor. Who is the neighbor? 192.160.2.2. It is the priority value is the by default 0. State is full. So this is the dead time value having the time limit. Then address is the 192.160.2.2. Which interface? Serial interface 00/00. So this is the interface to get the routing informations. Likewise, we need to check the neighbor router. So IP OSPF route sub neighbor. Here you can see 2.1. So 2.1 is the neighbor router, this router. Then state is full. Then dead time having the some limits. Then this value IP address is 192.160.2.1. It getting the routing information from this interface. Likewise, the neighbor routers 172.16.3.1 priority value is 0. The state is full. It having the timer. It having the IP address 172.16.2.1. It getting the routing information from this interface. Next. So IP OSPF database. Database is nothing but, I can explain already, it having the different type of LSE, router LSE, network LSE, then summary LSE. We can see database and the topologies. You can see so IP OSPF database. So IP OSPF database. It is the router ID which having the highest IP address. This is the this area, then this area. It having the what are the link state algorithm networks. Link ID is 2.1 is the first router, then 2.22 is the second router, then 2.3 172.16.3.3 is the third router. It having the advertised router ID 2.1, 2.2, 3.1. It having the some aging limits. Then what are the links counts here in the path? It will be same for the every routers. This is the area 0. Next one is so IP OSPF interface. So I can explain one by one. So this is the first router. It having the true interface G0/0, then serial interface 0/0. Here you can see 0/0, then serial interface. So the line protocol is up. Yeah, both are green. So that's why we need to confirm. It having the internet IP address 1.1. Here 1.1. Then right side having the 2.1. 2.1. Sorry, here 1.1, here 2.1. So this is the router ID. Which one having the highest IP address? It can choose the router ID. 2.1. 2.1 is common for both the routers in the same router. The cost value is different. Transmit delay 1 milliseconds. Then state is DR. Here point to point. This is the point to point link. Priority value by default it is having the 1. It having the hello time interval and date interval. You can see the time hello interval 10 seconds, then date interval having the 40 seconds, and it can wait for 40 seconds and retransmit within the 5 seconds. This is the hello time between the routers. Here adjacency with the neighbor router. Who is the neighbor router? For that interface, this one. So there is no adjacency. You must configure the here. So there is no other router inside the LAN topology. So we need to configure the passive interface. For this topology. So there is reduce the wastage of the routing information advertisements. You can go to the configuration. Router OSPF. Likewise, we configured in passive interface 0/0. Likewise, we configured in routing information protocol. It can stop the routing informations. You can see previously it having the hello time for that interface. Now we can see no hellos. This is the passive interface. So that's why we cannot advertise the routing information inside the LAN network using the command passive interface Gigabit Ethernet 0/0. Likewise, we need to configure all the routers. You can see. So all the interface it can advertise the routing informations. It having the 3 interface. So 3 interface it can routing the informations. I already told this is the IP address of the corresponding interface. This one having the router ID of the corresponding routers. This is the interface. Okay. Which one having the 0 bit 0 by 0 passive interface. 0 bit 0 by 0. It having the hello type. So it can advertise the routing information inside the LAN topology. It's not needed. Go to the router OSPF 1 passive interface 0 bit 0 by 0. After this command, you can verify the yes. Last but not least, enable serve. You can make that. So route OSPF. You can choose and view the what other interrupts are advertised in the OSPF protocol. So IP route OSPF. So IP OSPF interface. It does not need the inside the LAN interface. And go the command router OSPF 1 press interface 0 bit 0 by 0. Yes, correct. I hope you can understand the OSPF concept, and I want to thank you for watching this video. Please like and subscribe the Network Jungle and join the network adventure in Network Jungle. Thank you.